All right, let me start. My name is Christian Gross, and what I want to do is I want to talk about real-time communications with WebSockets. Some of you might know me in what I could call my previous lives. What I actually do as a living these days is I trade. You see right here? This type of stuff. This is my world. My world is the finance world. Now, if you might say, well, hey, excuse me, if your world is the finance world, why on earth are you standing on stage talking to developers? Isn't that a bit funny there? And the answer is definitely not, because my world, the trading world, has become your world. How many of you guys have heard of the high-speed trading algorithms? Okay, a few of you. Okay, I don't do high-speed trading algorithms. That's not my domain. My domain, though, is algorithms in general. So basically, what happens is I have a portfolio, my own personal money. Okay, I used to do work for traders, but now it's my own personal money. I have like 200 stocks, seriously, 200 stocks from companies all across the world. I can't manage 200 stocks just like that, right? I need algorithms to sit there and manage this for me. And one of the crucial things in algorithms is it has to be real time. It really does. I mean, you can't have delayed, oops, I'll buy tomorrow. No. It has to be real time. And as you can see right now, I am making money. The market is up. Now, in one of the pieces of this real time is WebSockets. The reason why I actually use WebSockets is because my applications that I write, and I used to write for my clients, were all web-based. Traders wanted native UI, but they also wanted web. And as such, the communications had to work quickly. See, Ajax and so on, that was so-so. They need real time. So while this talk will not focus just on the specifics of real time, it's actually given to you from the perspective of real time. It's given you from the perspective of someone who actually writes the systems. All right. So basically what I'm going to do is I'm going to talk a little bit about the history. The reason this is important is because man, I am old. I really am. I put this slide deck together, and I built my first web app, my first stock trading web app. I am not joking here. 1995. Okay? Anyone here remember the web used to be called the data highway? Okay, you guys are as old as I am. All right? Because most of the young, data highway? What the heck is the data highway? That's what the web used to be called beforehand. And I used to build web applications that would actually do stock trading, real-time tickers running back and forth. At the time, people were like, why would you want to do that? I said, no, there's a reason. So yeah, consulted companies. Actually, I used to consult a lot of large corporations. Believe it or not, banks, mortgages, and so on. All right, let's start with a little bit of history. How the web has evolved. About 95, 96 is when I started writing my first web apps. And in 1992, that's actually when the World Wide Web was created in CERN, it was meant for static content. That's all it could do, static content, a document. These days, if you were to look at that, you'd go, really? That's it? No, that was it. And that was a big deal back then. It really was. It was like, oh my God, there's a browser and it sees it. And then people like me started saying, static seems interesting, but you know what? I can send you that as an email. What's the big deal? I'd like to actually have a little bit more dynamic. So around 95, I'm not going totally accurate. This is from when I saw adoption and so on. 95, the concept of CGI was developed. At that time, a company who is now gone into history, Mosaic and Netscape. Those were the companies that actually drove the web at that point. And they created the CGI, which is Common Gateway Interface, to serve dynamic content we'll talk about. And then 1999, and this is something that has actually been lost in history, Microsoft was actually the one who created Ajax. Most people will say, oh, it just came from somewhere. No, it actually came from Microsoft. But in 1999, in the dot-com era, Microsoft was evil. And therefore, evil companies could not create good technologies. It was later adopted by other companies, Ajax, but that was when it was created. And then 2010, I'm going around. I know WebSockets was earlier. WebSockets came. The thing is that the original web was static, but now the web, for the most part, is dynamic. There's very few static pages left. That's really, actually, as someone who actually witnessed the web from its birth to now, I am stunned at how little static content there is. I'm not saying this is bad. That's not what I'm saying. I'm just saying that I remember when I saw my first web pages with the first images and with the first links, it was really what now would be considered primitive, but it was exciting back then. And now it's all dynamic, all about pushing data back and forth, and I find that good. So if people say, well, you can't build web apps with HTML5, I actually say, well, why don't you go back and look what web pages used to look like in '92? So how is dynamic? You see, when you have a web page and you want to show content, there's actually two ways that you can generate that content. The first way is you actually have JavaScript on the client side. And the second way is you have CGI templating or some type of server-side technology. This is the key thing, two sides. So what we're getting into with AED Web is classical client-server computing. Right? And we might not call that anymore, but that's what it is. You have on the client side some code that then makes a call onto the server side. Now, again, this going back a little bit in history, we used to call that RPC. And there used to be these old RPC technologies to make these calls back and forth. We don't have that anymore. What we have is we have JavaScript clients calling the server side using some type of communication mechanism. Now, the problem in the web is how to tie the client to the server and the vice versa. Well, the client to the server is not too much of an issue. The issue is server to the client, right? So if I have a browser and I have a web server here, I can make this call, no problem. The client can say, hey, tell me about something, no problem. The problem begins when there's a client and the server says, hey, I got some news for you. How does it talk to the client? That's where it gets difficult. Now, going back to the dynamic web of CGI, what we actually ended up using, and this was it's kind of like blurry these days, is we contorted HTML forms. We made all of these weird combinations. We created little, say, help me, I want to be here, I need attention. That's Charles, and if you notice, this is a Mac, and it's trying to get my attention. Yes, it's an unlicensed copy. No, I don't use Charles. I actually have other tools that I use, but I was thinking, okay, for this talk, I need to show you something which you can use, as you'll see, and I thought, oh, okay, I'll use Charles, except Charles is a little bit of a pain in the ass. All right, let's go back to the dynamic web CGI. The things that we used to do is we used to do really contortions. We used to create frames and then have content loaded in the frame and then have a meta tag refresh to sit there and get that and then somehow copy it from one to the other in the hopes that we could actually generate a chat. That's what we used to do in dynamic web for CGI. Now, the dynamic web became interesting once Ajax came onto the scene. That's where it really started. Because there were two key developments with Ajax, and this is something you have to understand about the dynamic web. The first key introduction is there was an ActiveX control which allowed a call to be made to the server side to get data, and it pulled back. But until that ActiveX control came into place, the way to submit the data into the HTML page was to create a new page. With Ajax, the document object model was created. Something that you now take for granted was not actually there before. That's the interesting thing. But with Ajax in 1999 around there, it came. So we actually had great ways to pull data, shove it in, and then move back and forth. That was the problem then in Ajax, and this is where I'm going back, the problem is the server. Browser, client, HTTP server. Client makes a call, great, but server wants to sit there and get an answer back. That was the problem. Because you see, here's how it goes. You have the Ajax request response. Client makes a request, time passes, and the response you get a server. That's very plain vanilla, straightforward. The client has to initiate request, and here's where the issue comes in. When I wrote an Ajax patterns book, which was like almost eons ago now, about 7 years, I think, there was the idea that the Ajax client would make a call to the server, and the server would hold the connection open. These days, it's called the comet pattern. And the problem with that approach is that you opened up a connection, but you're holding on to resources on the server side. HTTP servers were not originally intended for that. You see, originally, HTTP servers had the idea is that you made a call, you got your data processed, and you closed the connection, and you moved on. Very lightweight on the server-side resources. Come in, and back. Process goes down. Of course, we had things like fast CGI, and we had server optimizations where it would hold certain data resources, but overall, it didn't hold that many resources. It was a request, response, and that was it. The moment you have longer cycles, like in the comet pattern, you're using up a lot of resources. That's the issue. That's a big deal. Now, companies like Microsoft, servers like Jetty, Tomcat, Apache, they managed to put in patches that would actually simplify the issue of keeping these resources open. They would actually have optimizations built in. So we kind of solved that, but you know, in the initial time, it wasn't that great. So now here comes the question, why not server to client? I'm going to tell you again, I'm going back in history. 1995, I was living in Switzerland, Zurich, and I had a leased line. I had my own web server in 1995. All right? It cost a shitload of money. Do you see that? 1,500 Swiss francs. That was a lot of money then, and it's a lot of money now. All right? And that's per month. That's not like for the entire year. No, that's per month. And what I got was an entire 64K. Okay? I have, at our place now, we have, what is it running at? It's running at 60 megabits, right? The speeds don't compare. But the thing is when I was in 1995 having the server with the 64K ISDN, the internet, or everyone who worked on the internet, made the assumption that every server is on the internet. Now today, nobody would believe that, but that's how it used to be. I remember, I'm a mechanical engineer. I got my engineering degree in Canada, and when I was working on the Unix boxes, every box at the university was accessible to the internet, because everything was routed in. And at that point, making server-to-client communications was dead easy. Because what would happen is you would go in, and you'd say, oh, here, you have a notification. If anyone understands protocols, remember SMTP, which is still existent? SMTP relied on the fact that it would relay to the end machine. That at the end machine of the user, they would actually get the email. Now, can someone tell me why we don't have that anymore? Why don't we have that approach anymore? Yeah. Did you say that? Yeah, I'm being sarcastic. Firewall, really? No shit, no kidding. No, but why do we have firewalls? What happened? Thank you. Security. Does anyone remember the first Trojan that went across the Unix networks? It happened about 1993, 92. Anyone remember that? Essentially what happened is there was this hacker who really looks primitive by today's standard. Around that time, he created a Trojan that actually took down most of the university's networks. People were like, oh my God, why would somebody do that? Why would they take down our computers? Really, that was the thinking back then. I remember that very well. Why would they do that? And the answer is because they're malicious. This guy, actually, what he did, he just wanted to do it for kicks. Seriously, that was it. This was not some intention, but he did it for kicks. And so as a result, what happened is because of that, that's the thing, we now have firewalls. We don't allow communication in. Now that creates a huge problem for anyone who develops the web. Because what you now have to do is you have to figure out how to do a server-to-client communication, and the answer is a kludge. The comet pattern, as I talked to you about before, that's the kludge. You see, I'm trying to build up the context of why we're doing this, and here's the answer. It was because of firewalls. That's it, point blank. This is why we're dancing around. We're talking about this because of firewalls. We can't get through. This is why we have to do what we do. Because otherwise, we could have just had straight communications. Now, someone might say, well, wait a minute, but we're also running out of internet IP addresses. No, that's a secondary issue. Because what would have actually happened if we had all communications, like everyone had their own IP, what they would have done is they would have sit there and said, oh, you know what, we ran out of IP addresses much earlier, and then given out IP6. So, all right, WebSockets. The WebSocket architecture, if you think about it a bit, it has its origin basis in Ajax. That's really what you have to remember. There's Ajax, there's the comet pattern. Take those two technologies, clean it up, and that's what we call WebSockets. That's all you have to do. I mean, at this point you can go, you can drink coffee and so on, because you basically learned everything. You might not have learned the technical details, but you've learned it, that's it. So the idea is so that what we have is have a clean way for the server to communicate to the client, even though we have security and firewalls. That's where we go. So let's take a look at quickly how we can sit there and create WebSocket applications and how it communicates and how it works. All right. It's going to be running a Java application, but that's irrelevant for you. Right now, I'm just running a web server application. And right now, what I'm doing is I'm going to talk about here. You see this? Actually, can everybody see that, or is that really, really tiny? Okay, now I got to figure out how to increase this. View, zoom in. Zoom in more. View, zoom in. There we go. Do you see it's connected? Watch what I now do. I stop the server. Oh, it's disconnected. You may sit there and go, whoopee. Why is this a really big deal? I'm sorry? It's coming from the server, correct? But why is that a big deal? Okay, you didn't ask for it, that's right, but still, why is this a big deal? Who here does a lot of web apps, and what's the #1 problem you have between the client and the server when you're developing web apps? Open connections. That's right. What did you want to say?
There's no request for the response.
Exactly. You don't know when the client is there and not there. This has plagued developers of web apps so much because you're kind of like sitting there going, is she there? Is she not there? Is she there? Is she not there? Right? And then you make these wild assumptions and you cache and you put in and you create all these funny things to make sure to know whether or not the client is there anymore. Guess what? WebSockets gives you the ability to know when the client's there and when the client is not there. But there's a gotcha with this. You see, With web apps, it used to be nice. If the client went away, you had a cache, and eventually it sat there, and everything just went away. Yeah, but now that web apps with WebSockets tell you that, oh, look, client here, client not there, on the server side, you have to actually implement logic to close down connections. I remember when I was developing my first WebSockets, I was going, cool, everything works. For crying out loud, why are there 2,000 connections? It's only me. And what I forgot is, oh yeah, I kept the connections open because I thought someone would press the log off button. Well, yeah, me did not press the log off button. What you have to do, and this is something that I think no one has used ever, maybe they have, but how many of you have used the jQuery or the HTML unload page event? How many have used that? Only a few. Everyone has to put up their hand now because you have to now use your unload event. Because with your unload event, what you have to do, and this comes before the WebSocket gets disconnected, you have to send a message, hey, look, this person is about to refresh their page, or they're going to move away, they're going to do something else. Please shut everything down. You know what this has a resemblance of? A real app. You know, that's like, oh, look, a real application. It has on and off. And that's what this is about, WebSockets. That's why I'm saying it's a clean approach to the Ajax and Comet pattern. All right, so let's start up again. Okay, how many of you will say the web page will connect itself automatically right now? Do you see? I shut down the server. Okay, it said the disconnect event. I start up the server. Will there be a reconnect on the client page? Okay, you see, this is, okay, I'm going to put up your hands. Who says, yes, there will be one? Who says, no, there will not be one? Let's see who's right. No, there isn't one. Good try. But this actually brings up another interesting point in your application. You actually can reconnect. All right? What you can actually do is, if the server goes down and you get a disconnect event, you can put in a time delay system that will say, okay, you know what, let's retry the connection. And you then can connect to the server side. If it doesn't succeed, you'll get a disconnect or it won't work event, and you wait again. This again says, oh, look, I'm programming a real application because I have the ability to not force the user to refresh. This is the beauty of WebSockets. No more refresh button. Of course, the problem with that strategy is it's going to take about 20 years to teach people not to hit the refresh button. Okay? Because they're going to do it anyways. They're going to, oh, let's refresh, let's refresh, let's refresh. And we're kind of like, don't hit the refresh button. But, you know, that's another issue, that's another topic, that's not for today. So I'll hit the refresh button, shh. And what I can do now is I can type in hello. Ooh, look, message back, ooh-wee. Let's look at the source code of this. Okay, now, actually that's a bit small. Let me go a little bit larger on this. There we go. Let's hide this. Let's hide this as well. All of on the client side, this is all of the WebSocket code you need. Please ignore from one instance that there is some jQuery code. This here is jQuery. Just ignore it. What we need to focus on is this. This here is used to open up the WebSocket. You specify the URL, which in this case is WS, which means WebSocket. You also have WSS, which is SSL for WebSockets. It then goes to localhost 8080 WebSocket chat / anything. So this is the URL. So it's just like making a regular HTTP request, except the first bunch of letters aren't the same. What then happens is you implement 3 events. The onOpen, which says, I've made the WebSocket connection. The onMessage, which says, oh, look, here is data. And the onClose, which says, oh, look, the connection has been closed. The onOpen and the onClose in this case only sends out messages, or it actually will type in, oh, look, you've been connected or you have been disconnected. That's all it does, as you've seen just in the text box area. Now, in the onMessage, what happens is you get an event. And the event is a JavaScript object which contains a bunch of data. This bunch of data is whatever information is sent from the server side to the client. And in this case, we say event.data added to the text area for the text area that's already there. And then we do some animation to make it look like it's a chat. This is, again, jQuery that you really don't care about. But the key pieces are the 3 functions that you have to implement. Well, you don't have to, but you know, it's generic code. This is what you'll do. When I want to send a message, all I do is I reference the WebSocket and I hit the send message. That's it. It's really dead easy on the client side. There's really no complications. And this is what I really like about WebSockets on the client side when the client is a JavaScript client like HTTP. It works. It's straightforward. It also works all across the browsers, at least the new browsers. The one that I usually use to test, and a lot of the people that I work with, is we use Chrome. Why not IE? Well, no comment. Anyways, move on. Okay, let me see where I am in the slide deck, because I kind of have to... there we go. Just to make... Okay, yeah, I have to start. So this is on the server side. Sorry, the client side. Let's take a look at on the server side what actually ends up happening. If I take, in this case, a Java server, the way that it looks, the code, is I get a request, and all I do is I instantiate this WebSocket class that then implements the WebSocket on text message. And as you see on the server side, look at these methods: onOpen, onClose, onMessage. Now this is Java. Does this apply to .NET? Does this apply to Ruby? Does this apply to PHP? Now I got the bad news for you. On the browser, everything's relatively clean and relatively straightforward. On the server side, not so. Because what ends up happening is, here, let me get there, where is it? Yeah, here we go. On the server side, you have similar ideas, but they're not totally similar. You see, you still have the on new session connected, but then you have session closed and new message received, which is kind of similar, but there's little minute differences which I'm actually going to get to in a moment. What you have to understand is Microsoft has its own WebSocket implementation on ASP.NET, but it has its own API. And this is the only thing I find a little bit sad. On the server side, there is no similarity between the APIs. You cannot take the code from, let's say, one C# implementation and use it on another C# implementation. You cannot take the code from one Java implementation and use it on another Java implementation. This is really disappointing. So for example, I am right now, for the startup that I'm part of, we're using Jetty as a server. It's not going to work under Tomcat. And we're kind of like, oh, great. And why it's like that, I don't know. I don't know. It would have been nice if it was all standardized on any of the platforms, but it's not. I mean, the ideas are similar, right? New message received, new session connected, session closed. That's all similar, but not the API. What I now want to show is, what does this actually all do? Let's go back to Charles. Or did Charles exit himself? I think Charles exited himself. All right, applications. Charles. There we go. Yeah, Charles exited himself. Great. Okay, this is a proxy on OS X. For you Windows guys, you actually have, it's a better one. Fiddler, you guys know Fiddler? Use that and you can see how all of this works. What I'm going to do is I'm going to refresh and I should be able to get, there we go. Where's, we just hit. Okay, let's go back to Charles and let's see what Charles has showed us. Request, there we go. Take a look at that. Sorry, I can't increase the font on that one. That I'm sorry about. All right. Get WebSocket chat / anything HTTP1. Look at the next keyword, upgrade. This is the important bit. What happens with WebSockets is that WebSocket is HTTP. The catch is it upgrades the connection on the server side. You see, when we used to have the comet pattern implementation, what you would have is you would have a long-running URL, and heaven forbid someone with a browser called that just like that, right? You actually needed to ensure that when you implemented the comet pattern that it was not called up by non-JavaScript code. So with WebSockets, what happens is that it has to be explicitly code that calls it up. And therefore, in the header, it makes a request saying, look, I have an HTTP request. I want to upgrade it. And I want to upgrade it to a WebSocket. The response will say, yes, I will upgrade it. We can now talk WebSocket. This then leads us to the question, well, what does that mean? Let me type this in. Hello, how are you doing? Oops. Wait a minute. Okay, let's go back to Charles. There we go. Response. Take a look at that. Look at right there. Come on, you can do it. There. But Charles isn't responding. Can someone tell me what they think is happening right there? We've upgraded the connection. I've just put two text, and Charles keeps putting the text on, appending it one after the other. What's happening? Thank you. That's point number one. It's the same connection. Now, if this is the same connection, what does this mean? Keep going. You're on the right track, actually. You're really on the right track. Okay, so what we have is we have a client-to-server communication. The client makes a request, makes a connection. It says, I want to upgrade the WebSocket. Great. Server says, great, I'm going to upgrade. So they're now they're a WebSocket talking to each other. He's saying it's the same connection. Absolutely. What does that mean for the communications if it's the same connection?
It works in both directions.
Right, it works in both directions. This is really, really important to understand. A WebSocket connection is the comet pattern. It really is. There's no difference between the two. But on the client and server side, there has been an optimization such that you don't have to anymore deal with the nasties. That's really what WebSocket has done. And this is actually really interesting from my perspective, because what it means is we're actually going back to raw socket programming. Because that's what we're doing. We're just sending raw socket data back and forth. That's it. And as you can see in this example, the raw socket data is actually in text, as it's been witnessed by Charles, as it's been captured by Charles. All right, so let's go back to the slides. All right, yeah, what the demo code showed us is that each, okay, let's keep going. Let's look at closer at the protocols. All right, so what we know now is that the WebSocket connection is actually an upgraded HTTP connection, which then converts into a socket type connection. One of the things that you're going to see in a lot of the source code examples, if you do a lot of WebSocket, you're going to see things like HXIE 75, HXIE 76, Hybrid 07, Hybrid 10, and RFC 6455. All right. Ignore, except RFC 6455. For those people who were doing early socket development like myself, what happened is the WebSocket protocol was a draft. It wasn't yet finalized. And so what ended up happening is people would publish drafts and people would implement drafts, and then you would have all this communication back and forth, say, oh, does this work, does this not work, and so on. So originally what you needed to do is you needed to specify the implementation of the draft you're doing. Now you can ignore all that. Just focus on RFC 6455. Now, if you are using older browsers or older server software, just ignore it. Seriously, upgrade them. Do not use the old protocols. Stay away, because they actually have security holes. That's why the draft moved on. All right, so now actually I showed you some of the lower level details. Oh, sorry, what I now want to do is I want to explain a little bit more the lower level details of the protocol itself and so on. All right. When you have a raw socket connection, one of the biggest problems you're going to have is, well, what data is going to go back and forth, right? Let's say there's a client, they make a connection to the server, they say, I'm connected to this. Well, how do you know what data is going to be sent? You see, when you use HTTP, the request in HTTP is such that you have a header and then you have a body, right? Here, let's go back here. Let's look at Charles. Do you see that? Header. And the header describes what this packet is all about. And then in the body, you have all the information. When you have a raw WebSocket request, there's no more header. The header is only there in the initial connection. That's a problem. So therefore, what you actually need to do is you need to have the ability to define which protocol you're connecting to. And you're kind of like sitting there going, well, all right. Here's the server. All right. You're going to use the same HTTP server, except this client is interested in bicycles. It only talks bicycles. This client talks ships. So if I'm going to sit there and have a communication between the server and the client, how does the server know it needs to talk bicycles or ships? Well, in most cases, when you program, you would add a little header going, hey, I'm going to talk about ships, or I'm going to talk about bicycles. You don't have to put that into the header. You don't have to create your own packet to sit there and define, oh, I'm going to talk about ships or bicycles. What you do is you sit there and go and add on a header, sec WebSocket protocol, and in it you type in, oh, I want to talk chat 1.0. So if I go back into Charles, the place it would be, do you see here it says set WebSocket accept different header? But in here, in the initial connection, you would add that header and say, look, I want to talk this type of language. The thing is that it's this client that initiates which protocol on WebSocket it wants to communicate. This is not a server side. The way that it gets implemented on the server is that the client sends this information, the server reads this header, And if the server can process that information, it sends a packet back saying, great, I can do this. If it cannot, you must kill the connection. That's how the client then knows, oh, okay, I can't talk this protocol to this server. All right. The reason why you also want to do this is, and this is something I haven't shown, but is possible with WebSockets, you don't just have browser-based as clients. You can also have regular clients, Ruby, Python, C#, Java, Scala, you name it. They can be clients to a WebSocket connection. Now, these type of clients can actually accept binary data. In most implementations of WebSockets, there's a distinguishing between a text message and a binary message. On the web browser side, where I showed you the JavaScript, there is no distinguishing. It's only text. You can only send text ever. But on a non-browser-based clients, you can send binary. So therefore, you want to, again, use this header, this protocol within a protocol to say, well, look, guess what? Now I'm talking to a native client. Maybe I want to talk binary because it's a bit faster. Or I can do certain optimizations that I can't in text. All right, here's just a quick request. As I already explained to you, the client sends the header, receives the header, processes, and so on. Now, is WebSocket foolproof? One of the things I was actually given long thought about is how do we make sure that this WebSocket connection is a WebSocket, right? Because one of the problems, and I'm going to go back to, I just explained a little bit ago, is that you would have an AJAX client making a request to the server, and you wouldn't know if it's a proper client. You wouldn't know if it's maybe just a user who typed in a URL and just got that data. What you want with WebSockets is the assurance that whoever makes the call on the WebSocket actually uses a real toolkit, uses a real programming language, that it's not just a URL. And the way that you do that is you put in a specific header with a specific content that must be interpreted and sent back to the client. At this point, I'd like to add, you don't actually implement this. This is already done in the toolkits, but you do need to know a little bit about it just so that it's in my head, this information. Here's what happens. The client sends an additional header, sec WebSocket key, some value. Really, it's really some value. It could be, my dog is lucky. That's it, all right? That value is then base64 encoded. It's sent to the server and base64 encoded. So if we look at it, in this WebSocket connection, that with Charles, that should have happened. There we go. There it is. All right. This is not my dog is lucky. This is something else. But it's base, do you see here? It's base64 encoded. M4 whatever. Then what happens is the server unencodes this, reads the value, and adds the magic universal GUID. Yes, there is a universal magic GUID. And in this case, this GUID, they're concatenated together. The server gets the SH1 hash of it, which is basically the signature. UU encodes that value, sends it back to the client. If you look at Charles, yeah, 3, 2, 1. There we go. Do you see here? It took that value, it added the magic GUID, it UU encoded the hash signature, and the client will then process that and say, yes, you are a valid server. Simply put, it's like you make a special handshake, you know, wink, wink, hey guys, you know, knock, knock, 5 times, 3 times then, and so on. Or actually, if I want to be really cynical about it, you guys watch The Big Bang Theory, Sheldon? Penny, penny, penny. It's that. That's what it is. It sounds ridiculous why they would sit there and do it, but they did it because they know that some developers might want to sit there and hack it in themselves and do certain weird things. They want to stop that. Okay. So now what happens is we've made that connection. We've seen some of the lower details. We know that we can send data back and forth, but we know that this is a raw TCP connection, that bi-directional communications can happen. At this point, one would ask, why did we move back to a bi-directional communication network? Like, what's the big deal? I mean, that's not difficult. How many of you have done socket programming? Most of you. All right. How many have you done successfully, without pain, bi-directional socket programming? Actually, I like the comment. Don't put up your hand. He said without pain. Exactly. That's the problem. You see, to do bi-directional socket programming without pain, there's a lot of work that has to go into it. Because that's the difficult part. It also then gets into issues, how about doing server keep alive? Oh, you know, you're kind of like going, really, keep alive? Can't we just put the value at like 5 days and be done with it? Right? You know, there are all these little issues as a socket programmer which we don't really want to go through. See, that's what these guys did. They said, well, we'll do all these details. We'll create a standard approach, a standard implementation, so that you don't have to think about that. And that's what actually I find very good about it. So let's talk about pragmatics, because there are some issues. When I was first working with WebSocket programming, I thought, hey, great, everything works hunky-dory. Oh, crap, no, not everything works. Let me illustrate. Most web applications, what you have is you have a client browser, and in this client browser, you might sit there and put in some data, and the data goes around, but before you can put in this data, you have to be authenticated. Now, in the good old days, we used to use HTTP authentication, whether it be basic text or whether it be hash authentication. Nobody uses that anymore. Absolutely nobody. It's a kind of a shame, because what ends up happening is now we have authentication based on cookies. That's how it works. Essentially what happens is you have here, let me show it to you. Let's go in to here, Yahoo Finance. And right now, do you see Yahoo? I'm on the Yahoo page as nobody. So I click sign in. I give my password, which I hope I know. Now, before I click here, can someone tell me what the flaw of this login approach is with WebSockets? What issue am I going to run into on this method of authentication?
The cookie is tied to a specific URL or domain, and the WebSocket now uses the cookie protocol, not the US.
Okay, all right. Well, no, actually, okay, you're getting sort of in a. Why is Yahoo ask? You know, today it's first Charles starts bouncing its little icon, and now okay, you know what? We're going to ignore. But all right, let's go back. The comment was, if I use Charles and I'm doing a request, the request is basically going to send a cookie in once, and after the connection is made, that cookie won't be there. Yes, that's correct, but we have a cookie to associate with the WebSocket, so that's okay. You see, in the initial connection, what you have to do is you have to say, oh, look, this socket connection has this cookie, therefore all communication has to be remembered to be associated with this WebSocket. So, but you're getting on the right track. What problems do we have here? Seriously, it's a really serious problem. How did I enter the data? Yes. I'm sorry? Right, by hand. I entered it by hand. If I'm writing a Ruby client, okay, how is the Ruby client going to be authenticated? Is it the Ruby client going to type in by hand? Right. See, that's the problem. So you have this authentication mechanism, which is based on a monkey sitting in front of a screen, clicking on the URL, pressing a sign in button. Well, if I'm writing WebSocket code and it's a Ruby monkey, how are you going to tell the Ruby monkey to click on a URL, type it in, and press the send button? You can't. And that's the problem which actually I ran into right from day one. When you have WebSockets, the issue is that a client that is WebSocket only based, so that could be Ruby, PHP, C#, Java, they will only talk to the WebSocket. They will not talk in HTTP parlay. Underneath, what ends up happening is in the implementation, you start off with an HTTP request, it makes it, it upgrades the socket connection, converts it to a TCP request. So, you know, it does a flip. It doesn't upgrade, as it's so called. The problem is, in this upgrade, in this initial request, there is no cookie that actually is sent with the web browser. You see, the web browser sends the cookies automatically. If it's on a domain, it will send that cookie. So therefore, you can do that association. You cannot with a programming client. What that means for you is that if you're writing WebSocket server-side code, you need to rethink your authentication. You see, this is where I'm actually a little bit sad that we don't use HTTP authentication. Because HTTP authentication, even though it has a butt-ugly dialog box, actually would solve this problem. Because you see, if the server sits, the WebSocket like the Ruby, the PHP, were to make an HTTP request, it would automatically get the notification because of the way that the filtering system and HTTP servers work to say, hey, wait, dude, before you make this call, you need to be authenticated. And most HTTP client sites will give you the option to put a username password in. So then you make the request, server says, dude, you're not authenticated. It sends back, get authentication, it sends in the username password, goes to the server side, its server side says, yeah, that's acceptable, goes back and says, now you can make the request. When you do it per sign-in, that does not happen. Now, some of you might say, okay, I'll use HTTP authentication, but my company won't like that. Yeah, I know where you're coming from. I know the problems that you're facing. What you actually need to have doing, if you're not going to use HTTP authentication, you actually need to create a URL or somehow a web service request to say, look, I want to authenticate. What you can even do, this is what sometimes you can do in implementations, is you open up the WebSocket connection anonymously, and then in your communications back and forth, you authenticate. So you send in, the first step is, hey, I want to log into this application. And the server side sits there and says, oh, okay, you're making a login request, no problem, I'll process it. And then you make an association. It sounds a bit hokey, it sounds a bit, and the answer is yeah, it's because of that. What you really need to be using is the HTTP authentication mechanism. And then all of that would work without problem. More pragmatics. All right. Ooh. That's what I thought. Okay. More pragmatics. You're making a request from the client to the server side. Goes through. Can I expect this to be stable? What do you say? Why? No, it's not UDP, it's actually TCP. But still, can I expect this to be stable? No, actually your answer was right. No, you can't. Why? Okay, A lot of us have done socket programming. Socket programming has its issues. Part of it is, how do you know all the data is sent? Right? You don't know that. Well, TCP says, well, if you don't have a disconnect, your data will be sent because it's in a packet. That's what the TCP says. Great. I'm talking, let's say I send a long bit of data. What do? Do I send it all at once? Let's say I have to stream up 25 gigabytes of data. Do I do it in one shot? How many of you here would use socket programming and stream 25 gigabytes in one connection and hope everything works? How many would do it? Thank you. Nobody would do it because you can't. And you see, and this is something you have to understand about WebSockets. WebSockets solves a lot of problems, seriously. WebSockets is a good solution. But what it doesn't solve are the problems that messaging applications solve, right? MSMQ. You see, because when you have a messaging application, the additional things that are built in is consistency, reliability, and. That is not in WebSockets. You have to add that as your own layer. At that point, you're kind of going, oh, you gotta be kidding me. Really? I have to add that myself? Yeah, you do. But there is, and I'm sure Microsoft is going along this path as well, there are implementations of WebSockets, like Apache ActiveMQ, that has a WebSocket transport interface. You see, right now, we associate WebSockets with an HTTP server. Of course, it's an HTTP connection, so therefore it's the same. It doesn't have to be. There are a lot of standalone WebSocket products on the internet, like ActiveMQ, that will give you reliable WebSockets. So what you can actually do is you can have a web page, and then within it you make a WebSocket connection to the messaging server, and at that point you can start exchanging data, messages, reliable. This is handy. This is handy to have. But it goes back into the idea that you don't have a standard API, right? If I'm going to lock myself into ActiveMQ, and I really do mean that as in lock, you're going to stay with ActiveMQ. There's no portability to MSMQ. So therefore, you have to really think hard about which tools you're going to use. The other option is, if you want to be more independent, is you have to write your own messaging layer or your own reliability layer. Namely, what I'm sort of getting at is, look, if I'm going to be sending data, let me try sending the data in packets of 20, let's say the 25 gigabyte is split into 1 megabyte packets. So you have to sit there and say, oh, okay, I'll read 1 megabyte, send. Another megabyte, send. And then what you have to do is you have to get a handshake from the server saying, yeah, I got 1 megabyte. And then what you also have to do if you're doing crucial data, you have to sit there and say, okay, but is it the right data? You have to take a hash signature. Now, some of you might say, wow, that sounds really complicated. It depends what kind of information you're sending, right? If you're sending little messages, like let's say financial data, don't worry about it. Just send the packet out, the information will come back, everything will work. But if you're sending bigger packets of data, that's when you have to start thinking about reliability. That's when you have to start thinking about, okay, if I get interrupted in this, what do I do? Of course, I have the on-connect, disconnect, so I can sit there and say, oh, I've been disconnected. And I can recover. But you have to write that logic in. That's the key point. You have to put it in yourself. It's not given to you. So what it means from, actually, I talked about the protocol. So what it means is you have to look at all your different systems and we'll figure out which one's the best. But we've now come to the end of the session. And here's what I want to tell you about what I think about WebSockets and what you need to think about when you're writing code for WebSockets. First, I do recommend WebSockets. I use WebSockets myself. I've used it for messaging. I have another guy that I communicate with regularly. He's a trader programmer as well, and he uses WebSockets, and we really like it. You see, we used to use the comet pattern. It sucks, right? If you're trying to do real-time communication, sending data back and forth, the comet pattern just bites the big one. The WebSockets solves quite a bit. It makes it a lot easier to exchange data asynchronously. Now, when you're writing these type of apps, what you need to understand is WebSockets are like messaging applications. They are asynchronous applications, right? It's not RPC. You know, in RPC, when I sit there and say, here, client, request, response, that's it. WebSockets, it doesn't work like that. WebSocket says, I send a message, and then I get a message back. It's not in the same context. It's a messaging application. It's an asynchronous. It's a publish-subscribe. Therefore, your entire programming style has to switch. So what you typically do is you throw the message into the loop. That message triggers something on the server side, and then you receive a message and process with it. If some of you sit there and use Node.js, you'll go, hey, wait a minute. That sounds sort of like Node.js. There's a similarity. Absolutely. You could almost sit there and say WebSockets and Node.js fit like this, and they do. In your programming style, if you're writing a native client like Java or C# or Ruby or Python or PHP, you're going to have to get into that programming style as well. You're going to have to sit there and say, oh, I'm going to throw out a message, I'll continue processing, and then I'll get a message and I'll work with it. You have to get into the async mode. Now, the next thing that you need to do is you do not need to deal with the lower level details of the socket connection, which is really great. The only problem is you have to deal with the various toolkits, right? Underneath, pretty easy. Everything's done for you. Above, oh boy. The big browsers, including mobile, have no problem with WebSockets. It really works. I've tested it on the various smartphones. I've tested it on the various tablets. WebSocket works without problems. It's actually great for a tablet. And the reason being is that when you're working on a tablet HTML application, very often the problem you'll run into is you need to show content, but you don't want to go to another page. Because when you have tablet browsers, the page isn't kept if you switch tabs. Sometimes it gets refreshed. Right? When you're working on a tablet, you don't want to navigate away from pages too often. What you want to do is you want to have an in-page rendering and then continuously updating of it. WebSockets works amazingly well in this context. That's actually why I use WebSockets, because the applications that I'm building right now are for tablets. It's not for the desktop, it's not for the smartphone, it's for tablets. And there you have a bit of a different context, and WebSockets works really, really well. I'm going to have to tell you quite honestly, I haven't tested IE much. IE is not my world. My world is iOS and Android. That's really my entire world. I'm sure I've talked to some people who said the latest version of IE works well with WebSockets, especially the RF6422 and 651. You'll see, it's in my slides, okay? It works well with that implementation. So you can then go on. I am also very sure, even though I've never used it, Windows 8. I'm sure that there's not going to be any problems there with the tablet, WinRT, and so on using WebSockets. If you're a web app developer, give it a try. I think you won't be disappointed. Otherwise, move on. Thank you very much for the session. Hope you enjoyed it. Okay, thank you.